So hello everyone. So welcome to today's Leetcode daily question, that is implement queue using stacks. So the question is quite clear to us. We have to implement a queue using stacks. So for that, the hint given to us is that we can use two stack and for maintaining a queue. So as you can see here, the question will be given, and there will be some functions given to us which we have to apply to it. So the first function is myQueue. That is, we have to initialize the data structure. We will be, the queue. That is, we have to initialize the stack we will be using to implement the queue. Then push. Of course, we have to push the variable, the integer given to us to the end of the end of the queue. Pop. We have to remove the front element from the queue. Peek. We have to return the front element from the queue, and empty. We have to check whether the queue is empty or not. So we will doing it using two stacks. So the basic approach which comes to into my mind while doing this is to use two stack first of all, and then what I will do is that I will whenever we have been given, like, see, I have initialized the stack two stacks over here. So while pushing, if I get a call for pushing an integer, so I will push that integer to the first stack. Okay. So when I get the call for pop or peak. So what I will do is I will transfer all the elements from the stack 1 to the stack 2, and then I will, like, if you can see, I have pushed all the elements to stack 2 from stack 1 till stack 1 is not empty. That is stack 1 is empty, and then I have taken that that stack to pop in one variable a, and then again I have pushed all the elements of stack 2 to stack 1, and again then I have returned a. So this was one of the approach, and the second approach is quite space optimized, because in this approach we use O of n space complexity, while in the second approach, which I will be explaining further, we have used O of one space complexity. So now let's move to the solution video. So now let's first discuss the first solution. So as you can see, this is the function I've copied. So according to this, first, this is the question which I have made by myself to just test the scenario. So let's go on with the question. So first, my queues of course the two stacks will be initialized. So now coming to the next part, we have been given push two. So push two. So according to the solution, I will push whenever I will get a call for push, I will push it into the first stack. So two will be pushed. Again, three will be pushed over here. Okay. So now push four. So push will be four will be pushed over here. Now pop. As I said in pop, I will transfer all the variables of stack 1 to stack 2, then I will pop. So what I will do is I will move all the elements to stack 2, that is 4 will go that 4 will go to stack 2, and again this 3 and 2 will also go to stack 2. So let me finish this. So here I've pushed all the elements of from stack 1 to stack 2, and this is how our queue would look like, just to understand it more better. Like we add at the end, so 4 will be at the end. So now we have to pop. So as you can see, pop function is given over here. So pop. So ideally we have to pop 2, right? So that for that only we have pushed the elements of stack 1 to stack 2, so that we get 2 at the top. So we pop it. So we remove 2 for now. Okay. So now what next step is that, as you can see in the pop function over here, I have again transferred all elements of stack 2 to stack 1. So this is a bit tedious. So let me explain. I will explain you a further better approach in the second part. So for now, let's move all the elements of stack 2 to stack 1. So I will shift it for a minute. So I've shifted all the elements from stack 2 to stack 1. So now again we get a pop. So again, the same procedure will be taking place. I will shift from stack 1 to stack 2. And also you can see the change in queue as 2 is removed for now. So I will again do it. So now we get a pop. So again for the second pop, we will remove 3 from it. And also from the queue, 3 will be removed. So again now we have to shift 4 to the stack 1. So we shift this 4 to the stack 1. Now we get a push function. As you can see here, we have a push 5. So push 5. So we will ideally it should be added at the end. So here, as per our push function, I will push it to the stack 1. So it will be pushed over here. Now empty. Empty is basically I will check only like here if you see like once again just here. Yeah. So here I have returned it if stack we have to return whether the stack is empty or not. Since all my operations are mainly for with the stack one, so I have returned if stack one is empty, so return true, else false. Also for a peak, I'm not explaining you peak, but for peak also similar things will go on. Like same, we will transfer it to stack two, then we peak, and again we will move from stack two to stack one. So this is how the first solution goes on. Although it's a bit tedious, but this is how we have done in it. So now let's, and it is also getting accepted. So let me explain you the second approach now. So now this is our second approach. In second approach, what we have done, we have again used two stacks, of course. We've initialized it. Now for pushing, we will push only to stack one. Then if we get a pop or a peak function, so what we will do is we will transfer, we will check if it is empty. Then we will use a transfer function. So for transfer function, what we do is that in transfer function we have made it. So if stack 2 is empty, then while stack 1 is empty, we will push the element of stack 2 to stack 1, and again for the peak we will do the same thing. We will call the transfer function, and then we will uh, send the stack to the peak. Now you might think that it is quite similar to the first approach, but let us see in the solution video in the explanation how it is different. So I've copied the entire solution over here. As you can see, I've this is the functions given to us, and this is the transfer function at the end. So now let's go through it. So my queue, we will initialize the queue. Now push to as per the function written by us here. So push to, we will push it to the stack one. So okay, let's push to the stack one. Again, this will also go to the queue. Now push three and four, then push four. So I will push it to the stack one itself. Push three and push four. Okay. So now next we get a pop. So what for pop, what we do is we return if empty. Now what is if empty? If empty is simply return if both the stack, not just the first stack. Like in the first approach, we were doing if stack one is empty, so return true. But here we are returning if both the uh, stacks are empty, so we will return a true. So, okay, now we remove a transfer. So, what does transfer do over here? So, see, if you see transfer, so transfer function, if stack 2 is empty, yes, stack 2 is empty. So, while stack 1 is not empty, like while stack 1 is empty, shift the elements from stack 1 to stack 2. Okay, so while stack 1 is empty, we will move all the elements from stack 2 to stack 1. So we have moved all the elements from stack 1 to stack 2. Now p, now pop. So we will return stack 2 dot pop. As you can see over stack 2 dot pop. Let me show you completely. So stack 2 dot pop we are sending. So we will remove this two element from here and also from the queue for the understanding purpose. And now we will not shift again from stack to stack 1. So this is the difference. We will not shift again from stack 2 to stack 1. We will let the elements be in stack 2 itself. Okay. So now again we get a pop. So again we get a pop. So again we will is empty is false. So transfer. Now if stack 2 is empty, no, stack 2 is not empty currently. So we will not again post the element from stack 1 to stack 2 since stack 2 is not empty. So this will remain as it is. Now for now we will return s2 dot pop. That is 3 will be returned over here. So as you can see, it is a bit optimized solution because we are not again and again transferring. Once the elements are in stack 2, we are letting it the elements be in stack 2 itself. So again from this over here also it will be removed 3. So again we will get a push 5. That is push 5 we are here. So push 5 will now we will move to here this element. That is we will push to stack 1 as per our function return over here. So 5 will be attached to the queue at the end. Now we get a pop. So as per the question, again we have to remove the front element. So that is 4 should be removed. And so in pop we call transfer function. So transfer function now stack 2 is not empty. So again there will be no transfer happening. So now stack 2. So you have to return stack 2 dot pop. So again, stack 2 will be that is 4 will be removed. So as you can see, this is reducing the complexity too much bit. So here also 4 will be removed and we will get a 5 over here only. So now we get a peak function. So again, now peak function, we call it transfer function, but now stack 2 is empty. So now what we can do is we can transfer this phi, to stack 2, and then we will return the stack to the peak. So that is, we will return this stack to the peak. So here 5 will be returned. So 5 will be the answer to the peak function. Empty. Now since now for empty it will be false because stack 2 is not empty, and we will be returning true only if both stack 1 and stack 2 is empty. So this is how it goes. It is a much a better solution than the previous one. So this solution also got accepted, and it is a much better solution. So in this video, I have explained you two approaches. One was a naive approach, and second one was a bit a space optimized approach. So I hope you liked the video, and if you liked it, so please do like and subscribe. And thank you for being with me. Thank you.